Hello everyone, myself Deepak Sahu. Topic of this presentation is performance of energy distribution devices in mitigation of blast-induced vibration of reinforced concrete. This is the motivation of the study. When from 1995 to 2011, there are quite a few bomb blasts around the world, like Oklahoma, Colombo, Iraq, Pakistan, Indonesia. So many people are killed and so many structures have been demolished. So that I am using this kind of motivation to do the study. And this is the how blast-induced ground motion different from earthquake ground motion, because with the large amplitude, short time duration, and epicenter distance, the blast-induced ground motion will differ from the earthquake ground motion. So when a structure subjected to blast-induced ground motion will experience large acceleration in the post vibration phase, and if it survives this phase, it will undergo large acceleration in the pre-vibration phase. So specific study needs to be done. And bomb is an explosive weapon of any range which provides sudden violent release of energy from an exothermic reaction, and in that explosion the energy released as thermal energy, and some part of energy released into air and some part of energy released into soil, which is known as shock waves. So the characteristic of the blast loading affected by the following factors: type and size of the explosion, and the location of the explosion center to the structure. And there are 4 types of blast: free air blast, air blast, and surface blast, and underground blast. We are main focusing on the underground blast. And to know the peak particle velocity, we have to know what is peak particle velocity. So velocity transducers produce a voltage which is proportional the velocity movement and can be easily measured and recorded. So the ground vibration record shows the variation of the velocity with time, and the unit of the ppv is millimeter per second. And energy distribution devices is a simple design approach which tries to reduce the damage potential that coming from the ground or the air. And the advantage is damage is likely to be eliminated, and the relative storage displacement and response acceleration of the higher floors will be much reduced. And this is the classification of the energy distribution devices: passive, active, semi-active, and base isolation. Inside of the passive energy distribution devices, in this study we are using friction damper for comparison, and viscous and viscoelastic damper. So first one is the viscoelastic damper. Viscoelastic damper consists of viscoelastic layers bonded with steel plates as shown in the figure with viscous materials such as copolymer or glassy substances. Next one is the viscous damper. The total input energy will be distributed in form of kinetic energy, potential energy, and distributed energy through heat. And this is the objective of the presentation: to analyze the structure against abnormal loading condition, and to study the influence of the viscoelastic damper and viscous damper, and a comparison with the friction damper, and to select a suitable energy distribution device for the response reduction of the structure based on the performances. And to calculate the pp and ppv, we are using the formula from S. Chakraborty. And this is the output of the pp and ppv. So this is the input acceleration time history for the structure from 10 to 100. And this is the structure we are dotted from Kelly et al, and all the parameter kept constant in the. And for comparison, we are using free frame which has zero stiffness, and fixed frame which has large stiffness, and friction and frame with friction damper, viscoelastic damper, and viscous damper. First one is the interstored drift of the first floor of the example structure when subjected to 10-ton blast. Next one is the absolute acceleration response, and this is the interstored drift of the 5th floor when subjected to 100-ton blast. And second one is the absolute acceleration when subjected to 100-ton blast. So you can clearly see that the response reduction will good for all these parameters. For a viscous damper, it will be very good among three. And this is the maximum interstored drift response, and this is the absolute acceleration response for floor wise from 10 ton to 100. And from this we can conclude that energy distribution devices are found to be most effective controlling the response reduction of the building, and when subjected to viscoelastic damper, 25 to 60% of the interstored drift and 20 to 48% of the acceleration, whereas viscous damper will more 33 to 70 of the base shear, 35 to 75 interstored drift, and 30 to 60 absolute acceleration. So viscous damper is found to be most effective damper among the other dampers considered in the study for the response reduction of the ground. And these are the references. That's all. Thank you.